Okay students, now let us go for your third theorem, that is derive the equation of plane in normal form both in vector and Cartesian. Clear? So till now we have solved lines in space. Till now we have solved line in space passing through one point and passing through 2 points. So now we are solving the theorem on plane. Clear? So first let us draw the theorem which the terms are given. What are the terms given here? Normal form. That means derive the equation of plane in normal form. That means normal vector will be given to you. Clear? Normal vector will be given to you. Using that normal vector you have to find this theorem. Clear? Okay. So first let us draw x-axis, y-axis and z-axis, x, y and z. Clear? Okay. So by using this, let us take one plane on your x, y and z-axis, x, y and z-axis. This will be the plane and let us draw the normal. So this will be the normal to the plane. Normal to the plane means the perpendicular vector drawn to the plane from the origin will call normal of the plane. Clear? Perpendicular vector drawn for the plane from the origin will be called as normal vector or normal to the plane. Now I will take one arbitrary point P, because this is ON vector which is perpendicular to the plane. I will take arbitrary point P and I will join O to P. This will be the OP vector, position vector of point P. Now I will join NP. Clear? From the diagram here we can see that NP vector is perpendicular to ON vector. NP vector is perpendicular to ON vector. So using that, let us simplify this theorem. No problem. But you must remember normal vector ON will be taken as D dot n cap. Will be taken as D dot n cap. Clear? So D dot n cap means D will be the magnitude of ON. N cap will be the unit vector of ON, because whenever you are finding the vector, the formula says that unit vector multiplied with the magnitude will give you the required vector, because here the required vector is ON. So if I multiply unit vector with the magnitude of that ON will give me that vector ON. Clear? So using that ON, that is normal vector to the plane, now let us find our equation. Clear? Okay. Here what is OP vector? OP vector is vector R. That is position vector of point P. Okay. So from the diagram we can see that vector NP is perpendicular to vector ON. Vector NP is perpendicular to vector ON. Vector NP is perpendicular to vector ON. See, vector ON and vector NP are perpendicular to each other. So if two lines are perpendicular to each other, we know that their dot product must be 0. That means vector NP dot vector ON must be equal to 0. Either you write it here. This implies vector NP dot vector ON is equal to 0. Clear? That means if two vectors are perpendicular to each other, their dot product is 0. As you used in your straight line chapter, that if two lines are perpendicular to each other, the sum of product of their direction ratios are equal to 0. On the same way, here the dot product of the two vectors is also equal to 0. Same, everything is same, but it is in vector form. That's it. Clear? So now, what is NP? NP is OP minus ON. What is ON? First let us write ON as it is, equal to 0. Clear? Now what is OP? Here OP is vector R minus. What is ON? ON is D dot N cap. Again ON is D dot N cap must be equal to 0. Okay students, so now you are going to get vector R minus D dot N cap into D dot N cap is equal to 0. See here what happens. If this term must be equal to 0, this term must be equal to 0. Here what is D? D is magnitude, that means length. That is D must be not equal to 0. As usual we know that D is length. Length will be not equal to 0. So for that reason what we do, we take it as vector. We take it as vector R minus vector D dot N cap dot N cap is equal to 0. As you all know, while solving this equation, this is the product of two terms. In this product of two terms, D cannot be 0. This is first term, this is second term. D cannot be 0. Therefore, D is not equal to 0. What will be remaining thing? R minus D dot N cap equal to 0. So now multiply the terms. What you are going to have? Vector R dot N cap minus D dot N cap will be equal to 0. Clear? So now because N cap dot N cap is unit vector, again it will be N cap, no problem. So that is R dot N cap minus D dot N cap will be equal to 0. Therefore vector R dot N cap will be equal to D, because here N cap is unit vector. So N cap dot D will be only D. Clear? So vector R dot N cap equal to D. Clear students? So please remember that here N cap is unit vector, N cap is unit vector. If you don't remember the things, you slightly write here, that is N cap dot N cap equal to 1. You write N cap dot N cap equal to 1 because N cap is unit vector. Again N cap is unit vector. As you all know, I cap dot I cap is 1. J cap dot J cap is 1. K cap dot K cap is 1. On the same way, product of two unit vectors will be equal to 1. Here this will be okay. N cap dot N cap will be 1. N cap dot N cap will be 1. Therefore, from this we can say that R dot N cap equal to D. So this is your vector form. This is your vector form. Take it as equation 1. Clear students? So here ends your vector form. Clear? What is vector form? R dot N cap equal to D, because N cap dot N cap is 1. So here N cap dot R will be R dot N cap dot N cap will be 1. Therefore R dot N cap minus D dot 1 will be equal to 0. Therefore N cap dot N cap is 1. Okay. So now let us go for Cartesian form. In Cartesian form, see, R is written as xi cap plus yj cap plus zk cap, and n cap is written as li cap plus mj cap plus nk cap, because here n cap is normal vector. L and M and N are going to be the direction ratios of your normal vector. So N cap is written as Li cap plus Mj cap plus Nk cap. As you all know, R is the position vector. It will be written as Xi cap plus Yj cap plus Zk cap from equation 1. From equation 1, that is r dot n cap, that is xi cap plus yj cap plus zk cap dot with what? Li cap plus mj cap plus nk cap equal to d, that is magnitude. Clear? In the place of r you write this, in the place of n you write this. Clear? So now if you make dot product of these two, your theorem will be Lx plus my plus nz equal to 0. So this will be the proof of your Cartesian form. This is Cartesian form. Clear, students? Okay. So in Cartesian form, you write r as xi cap plus yj cap plus zk cap. You write n cap as li cap plus mj cap plus nk cap. So by using these two in your equation 1, you are going to have dot product of these two. I cap dot I cap is 1, j cap dot j cap is 1, k cap dot k cap is 1. So it will be Lx plus my plus nz equal to d. This is equal to d. Clear, students? So therefore Lx plus my plus nz equal to d, because in the LHS you have d, so it will be equal to d. Clear? Okay, this is what your theorem number 3. So in theorem number 3, this thing is very important, as well as ON you must remember. If you remember this, you can write NP as OP minus ON, ON as d dot n cap. You replace those terms. Here d is not equal to 0. So for that reason we get r minus d dot n cap equal to 0. Again r dot n cap, it will be remain same as it is. N cap dot n cap is 1 because this is unit vector. So you take minus d on that side. So therefore r dot n cap will be equal to d using Cartesian form. So very simple theorem, but you must be very careful while solving the diagram and while simplifying. Here you remember n cap dot n cap is 1, because we know that dot product of I cap dot I cap is 1, j cap dot j cap is 1, k cap dot k cap is 1. So for that reason you should remember those terms. If you multiply these two, you will get your Cartesian form. Clear, students? Okay.